Okay, here's an answer key video for the review for solving algebraic equations in preparation for the SWIC, which is coming up soon. Okay, so the first question, when it says solving by inspection, it just means we can look at the equation and just try to decide what the value of the variable is. So some number plus 14 is 20, so that's 6. Some number, when you subtract 5 from it, equals 35, so 40. Some number times 4 is 64. In this case here, these are two-step problems. And so I'm trying to think, well, if I were to add this to both sides, then I'd have 6 over here. So I have some number divided by 5 equals 6, so that's 30. And although it says inspection, you're welcome to use some of the strategies that we use, like balancing and inverse equations and stuff to help you solve. It says D here, it says E here, so it should actually be E. That's just a typo. So in this case here, if I were to subtract 1 from both sides, I'd have 10 on this side, and some number times 2 equals 10, and so that number's 5. And then this one here is a decimal number, and so if I were to divide 4.8 by 6, and I can use a calculator in this unit if I wanted to, 4.8 divided by 6, I get 0.8. These are also solving by inspection. Two equations are shown. What does the B represent? So 6a is 12. So where I have 6a, this is actually the same thing as 12. So this is kind of like 12 subtract b equals 8. And so I have 12 minus a number equals 8, and so the number is 4. So 12 minus 4 equals 8. Here's another solving by inspection based on the equation. What is the product? So that's multiplying of a and b. So in this case here, a is going to be 9 because 6 times 9 is 54. And if a is 9, then some number subtract 9 equals 14. So that makes b 23. Because 23 subtract 9 is 14. And then I have to figure out, well, what are they multiplied together? So 9 times 23 is 207. So that's the product. Down here, it's kind of like solving by inspection and different strategies as well. So across here, this plus this plus this plus this equals 49. These are 28. The sum of these are 72. The sum of these are 64, and so on. So I'm going to start with this because I have 3 of the same. It's kind of like 3 apples equal 24 in a way. And so 1 apple is going to equal 8. So I can say that my apple is equal to 8. And every time I see an apple, I'm going to say that that's 8 now. The next place I'm going to look is here, because I can see that I have 8 and 8. So I can get rid of those two. I can subtract those two. So I'm going to subtract 16 from 28. And if I subtract 16 from 28, I get 12. And so these 2 drums make up 12. That's kind of like 2 drums equal 12. And so 1 drum equals 6. So every time there's a drum, I'm going to say that that's 6. And I can check to make sure that they're okay. 6 plus 6 is 12, plus 8 is 20. So that one works, so I'm good with those two. Now I'm left with my ladybug. In this case here, if I look across the top one, I have 8 plus 6 plus 6, so that's 20. So these ones here would have a sum of 20. And all of them need to add up to 49. So if I were to subtract 20 from this, I'm left with 29. And so I'm saying that the ladybug is 29. And I can just check really quick across here. Let's say 29 plus 6 plus 29, and that equals 64. Which is what the answer is here. So these are my values of the missing variables. Okay, on the second page in question 5, we're looking for one-step equations. Now, one-step equations involve one step, either adding, subtracting, multiplying, or dividing, in order to isolate the variable. And isolate means we have the variable by itself. So I've already gone through and I've just circled the different things that are attached to the variable and essentially what we have to get rid of. So in the first one, it's x plus 13 equals 83. And so we have this plus 13 on the left side that we need to get rid of so that x can be by itself. And so what we're looking to do is subtract this 13. So instead of x plus 13, I'm going to subtract it. Now, you can't really just subtract 13 from one side like this, because then the balance won't be there anymore. If you're thinking like a scale, and we had two things on a balance, and you were to take 13 off this side, all of a sudden this side would be a lot lighter, and it would go up, and this side would go down, right? So we want to keep them in balance, because the equal sign basically means equivalent. So we have to do the same thing to this side. So we're going to be subtracting 13 from both sides. On the left side here, I have x positive 13, or plus 13 minus 13, which is just 0, so we don't have to write it anymore. And over here, 83 subtract 13, so that equals 70. So my value is 70, and I can try and check it back in the original equation to see if it works. If I were to put 70 here instead of the x, 70 plus 13 equals 83, and so that works. So what we're looking for is two steps here. We're looking for sort of you to show what you're doing to both sides and the answer. Okay, let's look at B. In this case here, I have m subtract 31. I have negative 31 attached to my m. And so I'm going to do the opposite of that, and I'm going to add 31 to both sides. Negative 31 plus 31 is 0, so I'm just left with m, and 41 plus 31 is 72. We accept either way, so if you wanted to write it like this and actually write out the statement again and subtract from both sides, you show that, or you can just show above what you've done to both sides. But we do need to see this part. So what have you done in order to isolate the variable? In this case here, it's y subtract 5. So we have a negative 5 attached to the variable. So I'm going to do the opposite of that and add 5 to both sides. That leaves me with y equals 34. In this case here, I have plus 13. So I'm doing the opposite of that to both sides. So I'm left with n on this side, and this side I have 3.5. Now, it's not just adding and subtracting, we can also multiply and divide. So if you look at E, the variable is attached to divided by 2. Okay, it's like half of n. So if you think of something like if this was our n and we only have half of it, that's equal to 4. And what we're looking for is to have a full n. So if I were to have a full n, I would have to basically double this, or times both sides by 2. And in that case, I'd have 8. This case here, I have 15n. So this is like a multiplication statement. So I want to do the opposite of multiplying by 15, and in this case here, it's dividing by 15. Now the reason why this works is 15 over 15, if you think about what that is, that's equal to 1. And 1 times n is just n, right? So we can write that. The 15s basically cancel out, and we're left with n here, and then 75 divided by 15 is 5. Down here we have the variable divided by 9, so I'm going to do the opposite, so that's times 9. The 9s are going to cancel out, and I'm left with 45. And here I'm going to divide both sides by the coefficient here, which is 11. And so 55 divided by 11 is 0.5. Down in these questions here, these open middle questions, you want to use the digits 1 to 9 at most one time. Now this one here, there's actually only 4 spots, so if you have those numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, you can't use the same digit more than once in here. And you want to create an equation where x has the greatest possible value. So I want this one to be as big as possible. So you got to think about how this is going to be put together. Since this is a positive number, in order to isolate for x, we're going to be subtracting whatever the value is here from both sides. And so because we're subtracting from both sides, I kind of want to make this value pretty small because I don't want to subtract a lot. And I want to make this one pretty big. So I want to make this 2-digit number pretty large. So the largest number that I can make with these would be 98. So I've used my 9 and I've used my 8. And then I have to think about what I can put here because I'm going to be subtracting this amount from this amount here. And so I have a 1 and a 2 left. So I guess the smallest one I can do is 12. And then if I were to prove that this works here and figure out the value of x, if I had 12 plus x equals 98, I'd have to subtract 12 from both sides. And then x is going to be 86. So I think that the greatest possible value for x is 86. And that's how I would do it. In this one here, use the digits 1 to 9, so same thing. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. and I have to create an equation where x has the least, so the smallest possible positive value. So it's kind of similar in a way, because I want to try to figure out what needs to go here and what needs to go here in order for x to be the smallest positive value. So I don't want to go into the negatives here. Now I'm going to look above because I already have these numbers. I already have 12 and 86 and 98. I'm going to see if I can use these to answer the question. So if I want it to be the smallest possible, and I know that 12 is the difference between these two, maybe if I leave 98 here, but instead of writing 12 here, I write 86. Okay? So that will give me 12. The problem with this is that 8 is used twice. So I can't do 86. I have to maybe do 76 instead, or something like that, because I've already used my 8 and my 9. Or maybe I can get something that's a little bit closer together as well. So you can try out different values here to see what the value of x is going to be. And the way you can look at it is the difference between these two numbers, you want it to be as small as possible. So if I look at these combinations, I can try to figure out some that are going to be pretty close to each other, and eventually I can work down to an answer. For example, I could do something like 29, so that uses my 2 and my 9, and 31. The difference between these two is only 2, that's pretty close together, and so I can use these. So instead of saying 98 here, because that's not going to work, right, because I have my 8 and my 8, I'm going to put 31 here, and I can put 29 here, because the difference between these two is only 2. And then when I'm solving this equation, I'd have 29 plus x equals 31, so I'd need to subtract 29 from both sides to isolate my variable, and I'm left with 2. That's a pretty small positive value. I don't know if you can get smaller than that. Okay, on the third page, we start with some two-step problems. So the two-step equations basically use the one steps that we talked about before, except we're going to be using SAMDEB as the order in which we need to isolate. And what this means is it's sort of the reverse of BEDMAS here. The first thing we're going to be doing is subtracting or adding. And what we're going to do there is that basically forces all of the variables on one side and all of the integers on the other. And then once we have that done, then our next step is going to be either to multiply or divide in order to isolate the variable. For exponents and brackets, this is going to be grade 8 stuff, so we're not going to worry about this right now. So let's go through SAMDEB. So the first thing here, when I look at 6n plus 5 equals 71, I want to have all of the variables on one side. So there are 6n, that's sort of my variables. So I have 6 of those over on one side, which means I have to get rid of this positive 5. In order to get rid of the positive 5, I have to do the inverse operation, so I'm going to subtract 5 from both sides. And that leaves me here with 66. So that's my S or A part. I use subtraction in order to make sure that all the variables are on one side and all the integers are on the other. Now I'm going to use multiplying or dividing in order to isolate for the variable, which means get n by itself. And if I want to get n by itself, I realize here that there's actually 6n equal 66. So my question is, what does 1n equal? And if I divide both sides by 6 here, I can see the 6 cancel out and I'm left with n, and 66 divided by 6 is 11. I can always go back and see if it works here by plugging this value for n into the original equation. So 6 times 11 is 66 plus 5 is 71, and that will give me the right answer. So you can always check your answers on these. For B, I'm going to start with, in this case here, subtracting 10 from both sides, because subtracting 10 is the opposite of this plus 10, which is sort of the constant on this side. And I'm left with 8b equals 32. And then I want to find out what 1b is going to be, so I have to divide both sides by 8, and that gives me 4. This one here, decimals, but the same process basically, so I have this minus 1.7, so I have to do the opposite, so that's adding 1.7 to both sides. So I'm left with n divided by 4 on this side, and on this side here I'm going to have 5.5. And then I have to get n by itself. So this is like a quarter of n is 5.5. So if this was n, I know that a quarter of it is 5.5. And so I have to multiply 5.5 times 4 to get through all of them, all the quarters. Or in other words, I'm doing the opposite of the operation here. And 5.5 times 4 is 22. Okay, in D, I'm going to add 9 to both sides. So I'm left with n divided by 3 equals 110. And then I have to multiply both sides by 3 in order to isolate for the variable, so I get 330. This case here, t's over here, so I want all the variables on one side. It doesn't matter if it's the right side or the left side, so I'm just going to make sure that all the variables are on the right side. And I'm going to add 5.6 to both sides in order to make that happen. So 12.4 plus 5.6 is going to be 18. And then if I divide both sides by 3, I'm left with t by itself on this side and 6. So t equals 6. And the last one here, there's sort of an extra step here. If I want to get rid of this adding 13, I'm going to subtract 13 to both sides. So in this case here, 30 plus 5 is 35, and then I subtract 13 from that. So I get 22. And then I'm going to multiply both sides by 2 in order to cancel here, and I'm left with n, and that's 44. Down here, there's some open middle problems for two-step problems. So this one is use the whole values 1 to 9. So once again, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can only use each of them once, and I want to find the largest possible value for x. Okay, so if I think about how this is going to play out, whatever is here is going to be subtracted from this number because that's the first thing we're going to do. So we're going to be subtracting whatever this is from both sides. So I want to try to make the difference between these two numbers relatively large. And once that happens, I'm going to be dividing this by whatever the coefficient is. So division is going to chop things in half. So I think that this should be my 1. Because dividing by 1 will just keep it the same. And I'll make this my 9. And because I want the difference between these to be the largest possible, but I can't use 1 because I've already used it, I'll use 2. And so if this was my equation and I wanted to simplify it and to figure out what x is, I would have to subtract 2 from both sides, and that would leave me 1x equals 7. And then if I divide both of these by 1, which, I mean, really, it's already there, x equals 7. So x equaling 7 is sort of the largest possible value that can exist here. Question 10, it's the same sort of question. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and I want the least possible positive value. So I want to make sure I don't go into the negatives here. So if I remember the first one, whatever was dividing by this became the denominator in a way. So I think I'm going to put my 9 here because I'm going to divide whatever my total is by 9, and that will sort of make it the smallest possible. It might be a fraction or a decimal, but that's okay. It just says positive value. It doesn't specify integer or anything. And then for these two here, I want to see if I can get these as close as possible, because in my mind, I want x to be 1/9 in a way. I'm going to be dividing it by 9, so I want to try to get this to be 1. So I can look at lots of different combinations. So my 9's already gone, but I can use any combination of these two pairings that are consecutive. So for example, I could put 1 and 2, because what would happen is, in order to get all the variables on one side, I'd have to subtract 1 from both sides, and I'm left with 1, and then I would divide both sides by 9, and I'm left with 1/9. Now I could do the same thing. I could do 2 and 3. So I could just subtract 2 from both sides, and that would give me the same thing. So as long as I pick two consecutive numbers, and I make sure that the larger one is on this side so it doesn't go into the negatives, then I should be okay. And I get 1/9, which is the smallest possible positive value. Okay, on the last page we have some equations. It's kind of like what we were doing earlier in the unit. So it's asking you to make an equation first. So let's start there. Cole was hired by his neighbor to look after his driveway while they were away on vacation. They told him they will pay him $15 plus $6 per snowfall to keep the driveway in good shape while they were away. So I have two of these values here, and I have to think about, is one of them a constant? Is one of them changing over time? And so this 15 is what they're going to pay him no matter what. I like to think about like what happens if there's no snowfalls, because T is the total amount of money that he gets paid and N is the number of snowfalls. So even if there's no snow, it never snows, he still gets paid that $15. So that's like sort of a constant. That's his starting value, or a zero term. And we're going to add to that $6 per snowfall, and N is the number of snowfalls. So total money that he earns is going to be 15, that's his constant, plus 6 times the number of snowfalls. You could have also said 6N plus 15 if you want. Okay, it doesn't really matter for addition if you switch the order. Okay, so either of these would work. It says, what is the minimum amount of times it would have to snow for Cole to earn over $100? Use your equation to help. So in this case here, let's say I want him to earn over 100. That's like the T equals 100, and I need to know the N. If I go back to the guess model, I'm given T, which is the total, but I'm not given N. That's what we're trying to solve. So I'm going to plug those into my equation. So I have T is 100. And now what we have is a two-step equation. So I'm going to subtract 15 from both sides, and I'm left with 85. And then I'm going to divide both sides by 6. And that equals 14.2, basically. Okay, so let's think about this. So if N equals 14.2, that's the number of snowfalls that would need to happen. If he only did 14, if there was only 14 snowfalls, then he wouldn't make $100. He'd make a little bit less than that. So in this case here, it would have to snow 15 times for him to make more than $100. And you can always go back and plug those numbers in. Like, so for example, let's try my 14. If N was 14, then I'd have 6 times 14 plus 15. So we'd only make $99, sorry, if there was 14 snowfalls, and it had to be over 100. For question 12, the difference. So that's the answer to a subtraction statement. The difference between two numbers is 100. So I have two numbers, and the difference of that is 100. One number is 5 times the other number. What are the two numbers? So here's one of my numbers. Let's say one of my numbers is N, and the second number is 5 times that number. So here's number 1, and here's number 2. So these are my two numbers. Number 1 is N, and the other one is 5 times that number. And I want to find out the difference between these two. So this is my formula. I'm going to have 5n minus n equals 100. And if I were to do that, let's say I had 5 n's, and I take away 1, I'm left with 4n. So now I have 4n equals 100, and I can carry through just like a normal one-step equation. Okay, so I'm saying that one of my numbers is 25. The numbers are 25 and 5 times 25, which is 125. This last one here, the sum, so that's addition. The sum of two numbers is 60. One number is 38 more than the other number. So one of my numbers is n, and my other number is 38 more than the other number. So here's my first number and 38 more. So these are my two numbers. I have n, and I have n plus 38. Okay, here's one of the numbers, and here's the other number. Now, what I want to do here, if I think about this, I have n plus n, so that's kind of like 2n plus 38 is 60. And now this looks like a two-step equation, so I'm going to continue solving as I would any other normal two-step equation. I'm going to divide both sides, and I'm left with n equals 11. So I'm thinking that the numbers are 11 and whatever 11 plus 38 is, so that's 49. And I can just test that. 11 plus 49 is 60, so that works.